Hello students, welcome in your online session for the 10th standard. We have started the chapter number 1, that is real number, and the video lecture number 1, that is the previous video. We have seen the introduction of this chapter. What is real number? What is Euclid division lemma? What is the meaning of lemma? What is the meaning of algorithm? And how we can find out the HCF using Euclid division lemma, that was already discussed in the previous video. Now this is the second video of this chapter, and now we are going to see again few sums related to Euclid division lemma. So we were solving exercise number 1.1 and question number 1 was discussed, right? Let us move towards question number 2 of your exercise number 1.1. So what is the question? Show that any positive odd integer is of the form of 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Show that any positive odd integer. Now you know that positive odd integer can be 1, 3, 5, 7, 9 and so on. These all are positive odd integer. Now the question is, we have to show this, all this odd number, it can be represented in the form of 6q plus 1, 6q plus 3, 6q plus 5. Every odd integer can be represented in this form. Okay, so for that, let us see what is Euclid division lemma. Now you know that Euclid division lemma says that any integer can be written as bq plus r. Any integer can be written as bq plus r, where r is a remainder and that should be either 0 or more than that, less than b. Right? So to prove that, see, here any variable is there. Whatever variable is there and whatever constant is joined with that variable, you have to consider that number as a b. For example, what is there beside q? 6. So we will consider this number as b. So here, take b is equal to 6. Now once you took b is equal to 6, your r is decided. So your r is going to be either 0 or more than that, less than b. What is the value of b? b is going to be 6. So can you decide the value of r? The value of r is 0 or more than that, but less than 6. So can I say that my r is going to be 0, 1, 2, 3, 4 and 5? 0, 1, 2, 3, 4, 5. Where 0, 2, 4 are the even number and 1, 3, 5 are the odd number. Let's try to take. We will take, first of all, we will take r equal to 0, which is even number, but b is going to be 6. Then we will take r equal to 1, that is odd number, but b is going to be 6. Then I will take r equal to 3, that is odd number, but I am going to take b is equal to 6. So for case number 1, all the case we have to try. So case number 1, r equal to 0 and b equal to 6. Right? Now put this value in the equation number 1. Put this value in equation number 1. So I can write a is equal to, b is your 6. So 6q plus 0. So a is equal to 6q. A is equal to 6q. Here the number is even. Right? Then let's see case number 2. In case number 2, what you have to do? You have to take r equal to next number. What is next number? 1, which is odd. And your b is going to be 6. So a is equal to 6q plus 1. Okay. A is equal to 6q plus 1. Next case, take case number 3, where you have to increase the value of r. Now you have to take r equal to 2, but b is going to be 6. So again, a is equal to bq, b is 6, q is q and plus r, 6q plus 2. Okay. Now next case, case number 4, where r you have to take it at 3, which is odd number, and b is going to be 6. So your a is equal to bq, that is 6q plus 3. Okay. Now take case 5, where you have to take r equal to 4 and b is going to be 6. So a is equal to bq plus r. Okay. Now case 6, where r you have to take it as last value 5 and b is going to be 6. So a is equal to 6q plus 5. Again it is an odd number. Now this is your odd number, this is your odd number, this is your odd number, and this is your odd number. See, all the odd numbers, can we represent it as 6q plus 1, 6q plus 3 and 6q plus 5? Yes. So equation number 2, equation number 4, equation number 6. Right? That is 1, 2, 3, 4, 5 and 6. So from equation number 2, 4 and 6. We can say that all odd number is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. Right? So every odd number can be represented as 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. If I'll explain in detail, suppose 13. 13, is it an odd number? Yes. Can you represent in any one of this form? Yes, I can. I can write 6 into 2 plus 1. See, q can be any number. Q can be any positive integer. But here it should be 6, here it should be 1. So 6 q plus 1. 6 2s are 12, 12 plus 1, 13. Suppose 15. So I can write 6 into 2 plus 3. 15 is the odd number. So 6 into q plus 3. 6 q plus 3. Suppose 17. Is it an odd number? Yes. I can write 6 into 2 plus 5. 6 2s are 12 plus 5. So every positive odd number, it can be represented in the form of 6 cube plus 1, 6 cube plus 3, 6 cube plus 5, where q can be any integer. Q can be any integer. So here also by using Euclid division, I prove that whenever I'm taking odd number, I'm getting the answer of number as 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. So your question number 2 ends. I hope you have understood. Let us move towards question number 3. Okay students, so question number 3, what does it tell you? An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in same number of columns. What is the maximum number of columns in which they can march? Now, one army contingent is there. Army contingent, right, of members 616. They are having 616 members, and one army band is there. Army band is there, and they are 32 in numbers. Right? Okay. So you contingent means so you can suppose that it is a group. So you can call it as army group number 1 and army group number 2. So there are two different group of armies. One are having members 616 and second one is having 32 members. Now they are taking part in a parade. Parade, you know, in 2600 means all the army men where they moving in a proper flow. That is called as parade. So I have to arrange all 616 members and 32 members, where when I make a column, like see this. Suppose I have made 4 columns. So in that 4 columns, all should arranged. This 616 also and 32 also, right? And each column will have a certain same amount of numbers. Are you getting my point? Same amount of numbers means what? Whatever so there are army contingent of 616 members and army band of 32 members. They are taking part in the parade, and the two groups are to march in the same number of columns. Now, suppose they have made their columns say 4 columns. Suppose 4 columns, right? In 4 columns, suppose 616 members has been arranged. So this group, that is the second group, they should have also arranged themselves in the 4 column only. It cannot happen that 616 is taking 5 column for their arrangement and this group is taking 3. Whatever column in which this 616 member has been arranged in the same column, but behind this 32 members should be arranged. Okay, so same number of column. So but obvious, this is something called as HCF. You have to find out the HCF of these two number. HCF of these two number means, suppose I have taken 616 members, right? So 616 comma 32. That is a 2 group. Let us find out the HCF of these two numbers, right? HCF, how to find out? So we know that using Euclid division lemma. So again I am explaining 616 divided by 32. So 32 ones are 32 That is this will be your 9, 5 minus 3 it will give you 2 and 96. 296, here 6 will come. And here you can say again, I think it is going to be 9s are. So let us say 9s are. 9 2s are 18, 9 3s are 27, 27 plus 1, 28. Right? 9 2s are 18, 9 3s are 27, 27 plus 1, 28. So 16 minus 8, 8. Okay, 8. That is your remainder. So how this 616 can be represented? It can be represented as 32 into 19 plus 8. Now further, we have not got the zero remainder. So again further division is possible. This 8 will be divisor and the 32 will going to be your dividend. So 8 4s are 32 and 0. So now how this 32 can be represented as 8 into 4 plus 0. So what is the HCF? Whatever the divisor which is making the remainder as 0. So your HCF is going to be, HCF of 616 is going to be 8. So what is the meaning of this? You have to make 8 column. 1, 2, 3, 4, 5, 6, 7, 3, 7 and 8. 8. So this all will be arranged here, and in the same column, this will also going to be this people will also going to be arranged. Meaning to say that divide 616 by 8. 8 8s are 56. That will give you 5. 8 7s are 56. So 87 member. This 616. How they will be arranged? 87 in first column. 87 here, 87 here, 87 here, 87 here, 87 here, 87 here, and 87 here. So all 616 arranged in how many column? 8 column. Now 32. 32 divided by 8. 4. So here 4 people, here 4 people, here 4 people. So all these people will arrange where each column will have the same number of these people and each number of column will have same number of these people. And how many total columns are required? 8. So it will look like a parade. If it will be different. Suppose the first group is having 8 column and second group is having 4 column or 5 column. The parade will not look nice. Are you getting my point? So to find out maximum number of columns for the arrangement of 2 groups, always you have to take the HCF of that 2 given number. And whatever the HCF, that is your answer. So that is how you have to solve question number 3. Now we are going to move towards question number 4. Okay students, so let us move towards question number 4. Question number 4 is quite similar to question number 2. Just a few things extra that I will explain to you. Use Euclid division lemma to show that the square of any positive integer is either in the form of 3m or 3m plus 1. Square of any number, suppose the number is a. So square of any number is either in the form of 3m or square of any number is either in the form of 3m plus 1. Now this is the question. Square of any number can be written either in the form of 3m or as a form of 3m plus 1. So let me give you a proper basic idea. For example, 5 square. That is square of a 5. What is the answer? 25. Can I write it as 3 into 8 plus 1? 3 into 8 plus 1. See, this bracket can have any number, but here it should be 3 and here it should be 1. So that is 3m plus 1. Similarly, if I'll write say 3 square. 3 square, again a square of number. What is the answer? 3 square, 9. So can I write 3 into 3? 3 into 3, that is 3m or 3m plus 1. Suppose 100 is there, 10 square, 100, right? 100. So can I write 3 into 33 plus 1? 3 into 33 plus 1, that is 33 into 3, 99, 99 plus 100. Meaning to say that square of any number, it can be represented either in the form of 3m or in the form of 3m plus 1. So let us solve this thing. Now here, whatever constant which is joined with the variable, here the variable is m. So whatever the constant joined with that variable, you have to take it as b. So here your b is going to be 3. And once your b is decided, you can decide your r as well. How? Your r is going to be more than 0, less than b. So your r is b. What is b? 3. So you can write r equal to 0, 1 and 2. R is 0, 1 and 2. Okay. Let's try to solve that. Let's take all the cases. So case number 1. Case number 1 where r is equal to 0 and b is going to be 3. For every case, Your B is going to be 3. So let's put in the formula. What is the formula? A is equal to BQ plus R. That is your formula. So A is equal to BQ plus 0. So A is 3Q. A is 3Q. But this is the number. This is the number. We are not talking about the number. We are talking about the square of the number. So square. So I have to get A square, I have to do the square on both the side. If they would have asked that as cube of any number, so I would have done cube on both the side. Because they are talking about square of a number, I got a number as A. To find out square, I have to do the square on both the side. So this will become A square. This will become 9Q square. 9Q square. But this is already given in equation that you have to represent your square of any number either as 3m or as 3m plus 1. So I can break 9 as 3 into 3. I can break 9 as 3 into 3q square. 3 into 3q square. Now this 3q square can have any answer. Any answer. Suppose the value of q is 1. So 1 square 1, 1 into 3, 3. But 3 into 3, that is whatever number is there, that is always going to multiply with 3. So I can consider this as any number. Any number. I am naming it as a m. So this thing can be written as a square equal to 3m, where m I have taken as 3q square. Where m I have taken as 3q square. I am least bothered about what is m, but it should be multiple of 3. So m into 3, yes, it is correct. First case. Let us move next number. Now I have to take r equal to, I took r equal to 0. Now I have to take r equal to 1. So let us take r equal to 1. B is going to be 3. So it will be A is equal to B Q plus 1. 3Q plus 1. Right? But again I have to find out the square. Square. So for square I have to do the squaring on both the sides. So this will become A square and this will become 3Q plus 1 to the whole square. So A square equal to 9Q square. A plus B whole square. A square plus 2AB plus B square. So 9Q square plus 2AB. 2 3s are 6 plus 1 6Q and plus 1. Okay. But obviously we cannot take 3 common from all the side. But we can take 3 common from these two. These two. We can take 3 common. So I can write this as A square equal to 3. 3Q square plus 2Q and plus 1. See, I only want 3. I could have taken Q also as a common. But we want only 3. So from these two, I took 3 common. Again, this can be anything. This can be anything. I will represent this entire answer with m. So it will become A square equal to 3m plus 1. Okay. Right. Let us take one more example. Case number 3. Case number 3. What does it includes? R equals to 2 and B equals to 3. R equals to 2 and B equals to 3. Let's put it down. A is equal to 3Q plus 2. Again, this is the number. I want square of the number. So do the squaring on both the sides. A square equal to 3Q plus 2 to the whole square. So A square equal to 9Q square plus 12Q plus 4. Now you should know this. A plus B whole square. A square plus 2AB plus B square. Now, again, at the last I should have only 1. I should have only 1. Here 4 is there. So can I write this thing as A square is equal to 9Q square plus 12Q plus 3 plus 1? 4 can be written as 3 plus 1, so that I can take 3 common from these 3 terms. These 3 terms I can take 3 common. So A square equal to 3, 3Q square plus 4Q plus 1 and plus 1 will remain as it is. From this entire 3 terms I took 3 common. Now again this thing can be anything. This bracket can be anything, but I am least bothered about it. It is multiple of 3, that is good. So this thing can be represented as 3m plus 1. 3, 2, 1. So from 1 to 3, we can say that square of any number is either coming as 3m or 3m plus 1. So here you'll write from equation number 1, 2 and equation number 3, square of any number is either in the form of 3m or 3m plus 1. Right? Okay. Suppose the next question, that is your homework, the same process is there and they are talking about cube of any number. Cube of any number. So instead of doing square here, you have to do cube on both the sides. One more thing, one more hint I am giving it to you. If you see the question number 5, next question, instead of 3m there 9m is there, 9m. So if you take directly b as 9, like I took b equal to 3, so I got 0, 1, 2, 0 and 2. If you take b is equal to 9, your r is going to be 0 or more than that, less than 9. So here 0, 1, 2, 3, 4, 5, 6, 7, 8. Too many iterations are going to happen. Too many possibilities are going to happen. So instead of taking b is equal to 9, take b is equal to 3. Why? Because 9 can be represented as a power of 3. 9 can be represented as 3 square. 9 can be, okay. So if a large number is there, suppose 8 is there. So you can take b equal to 2. Why? Because 8 can be written in the power of 2. If 27 is there, 27m, still you have to take b equal to 3. Because 27 can be written as the power of 3. So 9 is coming, 27 is coming, still you have to take b equal to 3. 8 is coming, 16 is coming beside the variable, you have to take b is equal to 2. So question number 5 is your homework, and this exercise is over, right? Whatever doubt is there, you can ask me at any moment, right? So question exercise number 1.1 is finished here.